Okay, so once again, ran out of time here. So we're going to have a kind of go back and look at that one, but I did get the answer down, um, right before the time expired. And so the, the, um, the value has to be exactly what I got, which is this negative 2,219.9. If you did not get that, just run it through again. Just be really careful of things like these negative signs that are all over the place. Those can just get you in a ton of trouble. So use your calculators, parentheses, order of operations, and you should be okay. All right, so there's the answer. And then that of course is a delta H. That's a delta H, delta heat of formation. It's basically finding delta H, which is the same as Hess's law, same as bonds, same as everything else, just using this formation data, which means they give us the compound and then they give us the value for that particular compound. So, all right, I want you to try one on your own. I want you to pause the video. I want you to dive in and I want you to try this example number 12. Formula is there. Formula is balanced. You do need it to pay attention to balancing, but it's ready to go. So go ahead and try that. Then I'll work through it. All right, should have paused the video, gone through this, worked through it. If you did not, if you're just watching me work the magic here on these problems, remember that just watching me do them doesn't really mean you know how to do anything. So just be aware of that. So, okay, so the delta H here is a delta heat of formation. So I want to start to remember that delta heat of formation means I'm going to take my products and I'm going to subtract my reactants. We want to just be really, really, really good at just constantly saying products minus reactants. Okay, so calculate delta H for this. And so I'm going to start with my products. And they're not particularly interesting because they're all ones. So this one's a little easier than the one before, but hopefully you spotted that. So let's go ahead and do 1, because there's 1 carbon dioxide, times carbon dioxide's value, which is right there. So times negative 393.5. Okay. Going to add that to the water. So we're going to do 1 multiplied by water's value. Now notice this is liquid water and this is also liquid water. So that is a good thing. Negative 285.8. So there's my products and they are going to be in brackets. Now we're going to subtract the reactants. So this first one, there's 2 of them. So 2. But look, it said that the hydrogen ion was 0. It's not actually an element in its standard state. It's an ion, but it's still giving us a value of 0. So that's not how hydrogen looks normally. So they did provide us with the 0 because it happens to be 0. So 2 times 0 is 0, but not a big deal. And then we're going to add that to the last one, which is 1 times the value for the CO3 minus 2, the carbonate ion. So minus 677.1. And then I'm going to bracket that. And then we're going to run it through. And you're going to see if you got the right answer. So delta H is going to equal whatever the heck we ended up getting. Now, once again, I am adding some things that maybe mathematically don't do anything, but I'm still putting the ones in there because I want you to get in the habit of saying that it is important that I'm paying attention to those ones, because they might not always be ones, right? So that's why we're doing it. So let's go ahead and run through. So make sure that we get the right answer. And I'm going to do the negative 393.5 plus the negative 285.8. Actually, I typed in my calculator wrong, so I'm going to try it again. Negative 393.5 plus the negative 285.8. And then I'm going to subtract, in parentheses, I'm not going to mess with a zero, negative 677.1. And when you do all that work, go through all that effort, you get an answer of negative, did you get it right? 2.2 kilojoules, right? Negative 2.2, right? So what are we taking away from this? Products minus reactants, products minus reactants. That is really the key. And again, these are things that are going to be on the test. There is no, there's no mystery here. You're going to see problems like this on the test, and you're going to get them right because they're easy. Okay. How do students get these wrong? They just careless with their math, or they make a mistake, or they don't pay attention to these coefficients in front. So otherwise they should be okay. Now, if it's graded on like a multiple choice or something like that, then just be really careful and double check your math. Don't take your math for granted. If you have time, you go back and you work it again. And if you get two different answers, then you work it a third time to figure out which one you want to go with. So, all right. Last thing here, this is going to be a little weird. If you have a combustion value given to you, and so what I mean by that is that they're saying, hey, use combustion data. That doesn't mean they say solve for combustion. They say use combustion data. So if you have combustion data, delta H sub C data, only, that's the only time we use this, okay? So if you have delta H sub C data, then we're going to use this formula. So what is going on here? Instead of products minus reactants, it's reactants minus products. This rarely ever comes up, okay? It almost never comes up. So I want you to write down that this is not on the unit test. It could be on the IB test, but it's really sneaky if they do that. So this is just something to come back to and study before the IB exam. It might be on the IB exam, but you have to have combustion data. Now here's the problem. Combustion data is in the data booklet, okay? Now, we're not going to spend a bunch of time with this because it's not on the unit test. You have a lot of other things to go ahead and to know, and I'm just going to write the answer down to this so you have it in your notes. But once again, this is not on the test that you will take for me. It could be on the IB exam, but it's very rare. Okay, so I'm just going to write this down real quick. Now, I guess one thing I should point out is this does need to be balanced, because it's not balanced, which is a problem because we're looking for one glucose and the rest of it's not balanced. So I balanced it up real quick, and then it's just going to be it's going to be reactants minus products, which is opposite. And it's because they're finding this data in a different way. Instead of making things, they're combusting things. And so then that gives you a different set of data. If you found this answer using delta H sub F data, and you did products minus reactants, you would get basically the same exact answer. So remember, we can solve these things in a bunch of different ways. I just don't want to spend a lot of time on this one because it's not going to be on your test. And you guys got a lot of stuff to know. No reason to muddy the waters with something that you just don't need to know for my test. So once again, why do I not spend a lot of time on it? Because it just rarely comes up on the IB exam. So we're going to buy ourselves a little bit of time here. And there you go. So you have it. You can study for the IB exam. It's not on the unit test. You might want to make a note that it might be on the IB exam. And so as long as you remember that it's backwards, you'll be fine. So, all right, guys, we are gonna we're gonna stop here. And once again, this page not super important for you, and so this is gonna get us through this section. And then when I start up again, I'll be looking at a delta G, delta S, and some new things, and they'll be kind of closing it down.